Hi there, this is Mr. Alexander, and I am here to show you the notes and the homework that we did in Pre-AP Algebra 2 on August 28th and August 29th. We did a few things in class. We talked about relations and functions, discrete and continuous, domain and range, and parent functions. The first thing I want to talk about is these notes that we had here. That should have been given to you by your teacher. And these won't be in your journal. These won't end up in your journal. This is just notes for you, the stuff that will probably be on the test. And we're asked to determine if the following relations are functions, then state the domain and the range. Well, this first one here, the way you determine whether or not something is a function from data is you look at the x's. So these are xy coordinates. And if any of the x's repeat, like they do in this case, this one and that one, then it's not a function. So that is not a function over here. 1, 2, 3, 4, 5. There are no repeats in the x's there. So that is, yes, that is definitely a function. Now the domain, what I like to think of is all of the x's, and the range is all of the y's. And so we just list those as a set, like they're listed above. These coordinate points are listed as a set. We're going to do that again here. And you just list all of the x's. So 1, -2, -1, and you don't have to list the 1 again. You shouldn't. You only list it once. And that's the set. It doesn't matter which order you write the numbers in, as long as they're all there in the set. And the range is all of the y's. So that would be -2, 0, 2, and 3. That's it. That's the domain and range. All of the x's and all of the y's. So they kind of ask us to do the same thing down here at number 6. Saying, write each of the following as a relation, state the domain and range, and then determine if it is a function. So let me zoom in on that. Okay, so to write the relation, it's just asking us to identify the coordinate points, the coordinates of all these points. So I'm going to do those weird bracket thingies again. Now this first one is over 2, up 3. So that's -2, 3. Remember, we're writing x, y coordinates. Alright, so that one's gone. The next one is, we don't move over at all, it's just at the origin, and then up 1. So that would be 0, +1. Then it's over 2, down 1. 2, -1. Then it's over 3, down 2. And then those brackets there, I ran out of space, but it should be those weird looking bracket things. Now, again, the domain is just all of the x's. So x's. So it would be -2, 0, 2, and 3. There's no repeats there, so you write them all. The range is all of the y's. So that would be 3, 1, -1, and -2. There's no repeats, so write them all. And then, is it a function? Well, do any of the x's repeat? No, they do not. So, yes, that is a function. So that's how you're going to do 5, 6, 7, and 8. Now let's talk about 9 through 12 real quick. It says, express the following relations as a mapping, state the domain and range, then determine if it's a function. Okay, so I think we maybe ought to do number 12. And before we do a mapping, I think it's easier to list the domain and the range and whether or not it's a function. Alright, so the domain is all of the x's. The range is all of the y's. So let's list those x's. 1/2, 1/4, 1/8, and -1/2. And there are no repeats in those x's. So yes, that is a function, because none of the x's repeat. Yes. The range is all of the y's. And that's going to be 2. And they're all 2. 2, 2, 2, 2. So there's only one thing in the set there. They're all 2. Write that 2 a little bit more clearly. 2. Now, we can do the last thing we're supposed to do, which is make the mapping. In a mapping, you just list the range and the domain vertically and in numeric order. So the range is just 2 over there. We're going to put a little box around that 2. That's the range. The domain in numeric order is -1/2, 1/8, 1/4, and 1/8. Actually write that a little bit differently. -1/2, 1/4, sorry, 1/8, 1/4, and 1/2. And we're going to draw a little ellipse around that as well. Now mapping is simply a depiction of the relation. And we're going to say, it's a depiction of the domain and range. So that 1/2 goes to 2, that 1/8 goes to 2, that 1/4 goes to 2, and that 1/2 goes to 2. So you just draw arrows from the input to the output, or from the domain, the piece of the domain, to the piece of the range. Now the way you can tell from one of these mappings, if it's a function, if 2 arrows come from the same piece of the domain and go to different y's, that's not a function. In this case, yes, it is a function. All right, so that's 9 through 12. And one thing I didn't say about all of them that we've done so far, is that they are all discrete. Every single one of these is discrete. Data is discrete. And it's the difference between discrete and continuous. So lines, if there was a line drawn between all these points, that would be continuous. But since we just have individual points, that's discrete. So for instance, on 13 through 18 through 25, these are all continuous. When you're dealing with individual points, that's discrete. When you're dealing with lines, that's continuous. Now, I'm going to do one of these for you. We're doing the same thing here. We're just supposed to decide if it's a function, whether or not it's a function, and then we're supposed to state the domain and range. So, I want to show you number 16 here. And to determine whether or not it's a function from a graph, the easiest thing to do is do the vertical line test. And that vertical line test is you go from left to right. And if you ever touch more than one point at a time, it's not a function. This thing passes the vertical line test. I'm only ever touching one point of this graph at a time. I'm only touching one point on this function at a time. So it passes the vertical line test. That's a yes. Now, to do the domain and range here, it's the same idea. It's still all of the x's and all of the y's. But now, we're not going to list individual points because there's a lot of x's and there's a lot of y's, and we couldn't possibly list them all. So we use something called interval notation. In an interval notation, we're using brackets and parentheses. And a bracket means inclusive, where you include that point. Bracket means inclusive. A parentheses, little happy face there, hello, means exclusive. So I'll talk about what that means more in just a moment. But when I'm doing domain and range of a continuous function like this, I like to ask myself two questions for both the domain and the range. In the domain, the two questions are, how far left and how far right? So, if I'm looking at this thing, and I'm trying to decide, if I'm looking at the x-axis and I'm trying to decide how far left and right this thing goes, I'm going to assume there's arrows at the end of this sine function. And I'm looking at it, how far left does this thing go? Well, it never stops going left. So what's that point way out there, out in the negative direction forever? We call that negative infinity. Put a little comma there. How far right does it go? Well, this thing's going to go way out there in the positive infinity direction. Now this thing approaches infinity, but because it's infinity, it'll never quite get there. So we use the exclusive brackets. Another way you could say this is all real numbers. All right. Now for the range, you're going to ask two different questions. How low and how high? And it's the same thing. So how low does this thing go? Well, it looks like it touches this line, y equals -1. So the lowest point it gets to is -1. How high does it go? Well, it looks like it touches, at the very highest point, the line y equals 1. So it gets to 1 right there. Now the question is, which do we use, brackets or parentheses like we're using up here? Remember, the brackets are inclusive. It does touch -1. So we're going to use a square bracket. And it does touch +1. So we're going to use a square bracket. Let's do one more like that. Let's do the circle on number 22. Number 22 there, that's circle. So again, the domain is all the x's, the range is all the y's. So how far left, how far right? The furthest left this thing goes is right here at -2. The furthest right it goes is right there at +2. -2 to +2, and all the numbers in between. And it actually touches -2 and +2. So those are inclusive. What about the range? How low? Well, that's -2 again. How high? That's +2 again. -2 to +2 and everything in between. So that's inclusive. It touches -2, it touches +2. Is it a function? Well, that's the vertical line test. Right there. Look, I'm touching 2 points. This thing fails the vertical line test. So that'd be no. This is not a function. So that's basically it. That's discrete, continuous, relations, functions, and domain and range. And next, we're going to talk about parent functions. So parent functions. Your teacher should have given you these 3 sheets. This is linear, quadratic, square root, rational, cubic, cube root, and absolute value, exponential, logarithm. And parent functions are the most basic functions. So it says y equals x. That's a linear function. If it was x plus 3, that's not the parent function, because the parent function is the most basic. It's not 2x, not 2x plus 8. It's not 2x squared. It's not 2x squared plus 4. It's just as basic of a function as it can possibly be. Those are the parent functions. And you'll need to be able to identify all 9 of these. So what I'd like to do is show you how to do a couple of them and help you on your way. So the first one I'd like to show you is quadratic. And these quadratics, let me just readjust here. To fill out this table, there's a couple ways that I like to do this. One way is you could just take the x and plug it in for the function. So, like if you take -2, plug it into x squared, that would be -2 squared, which equals 4. Or over here, 7 squared equals 49. Another option is to use your handy-dandy calculator. Turn it on. You're probably going to want one that's not broken. Let me go get a different one. Alright, that's better. And if you go to y equals, and you type in the function x, and down here to squared, what I like to do is I like to go to second table set, and then go down to this independent variable and change it to ask. And what that's going to do is when I pull up the table, it's going to ask me which x value I'm interested in. So if you go second, this button here, second, right there, and then table, that's going to get you there. So second table, and it's asking me what x I want. Well, I want -9. All right, so that's 81. I want -7. All right, that's 49. I want -5. That's 25. -3 is 9. Hopefully -2 is 4. Okay, good. That feels good. -1 is 1. 0, of course, is 0. The nice thing about the quadratic function is that it's symmetric. So all of these ought to be the same as the ones that I did previous. 4, 9, 25, and 81. So that's one thing the calculator is nice for. Another thing it's nice for is helping you get a sense of what the graph looks like. In this case, quadratic is parabola. And when you're graphing it, I recommend you graph as many points as you feel are appropriate to get the general shape. For quadratic, I'm going to graph 5 of these points. So 1, 1, -1, 1, 2, 1, 2, 3, 4, 2, 1, 2, 3, 4. Okay. And then you should be able to draw that parabola. Make sure you get some arrows on there. And there you go. That's a good way to use a calculator to help you get the table and to get the graph. Now, we're going to do the domain and range just like we did previously on our notes. And so the questions are still the same. It's all the x's, it's all the y's. How far left, how far right? Well, I'm looking at this thing. How far left does it go? Well, see these arrows? That means it's going off in that direction forever. So if I keep going left, at some point I'll be able to find a point on the graph for this parabola. I may not be able to see it because it's really high, but it goes out there forever. It goes out to -infinity. And it does the same thing on the right. It's going up and to the right forever. So the question, how far left? It goes to the left forever, and it goes to the right forever. So this is all real numbers. So we'll put those in parentheses. The range, though, the range, how low does it go? What's the lowest y on here? Well, the lowest it goes is y equals 0. How high does it go? It goes up forever. That's positive infinity. Now it touches that 0, so that's inclusive. That's parentheses. And it approaches infinity. It's not going to get there. So the y-intercept is where it crosses the y-axis. It crosses right there at the origin. It's 0, 0. In this case, it happens to also be the x-intercept, where it crosses the x-axis. So that's 0, 0 as well. A maximum occurs when a function goes up and comes back down. Well, this thing goes up, but it never comes back down, so there's no maximum here. That's a none. Minimums occur when a function goes down and then comes back up. This thing does have a minimum right there at its vertex. That's going to be 0, 0. Now, symmetries. Is this thing symmetric? Is there some line we could use to cut this thing right in half so that it's the same on both sides? The answer is yes. It's the y-axis. The y-axis is a line. And the way we write lines that go straight up and down vertical like that, it's like this. X equals 0. It's symmetric around the line, the vertical line, x equals 0. And does this thing have an asymptote? Well, maybe you've never heard of an asymptote before. But an asymptote is basically a line that a function approaches but never quite reaches. We're going to show you one that does that. This one isn't one. This one has no asymptote. None. So that's how you do quadratics there. But let's talk about one that does have an asymptote. Let's talk about logarithms. Logarithms. That's this one right here. Let me zoom in on that. So the first thing we need to do is fill in the table. I'm just going to use the calculator if that's all right with you. I'm going to clear this out. I'm going to go back to y equals. And I'm going to press the log button, which is right here. There's your log button. And I'm going to do the log of x. Log of x. And window, okay, it's still asking me. That's good. I changed that to ask, going to second window, second window, table set, ask. Now if I go second graph, all right, see all these errors? That means they don't exist. It's not, you see, you can tell by the graph that there's nothing going on over on this side. So all these negatives, I'm just going to put dashes for those. Those ones don't exist. But I am interested in 0. So type in the 0 there. And that's an error as well. But what about 1 over 1,000? Well, that one it will give me. That's -3. How about 1 over 100? That's -2. How about 1 over 10? That's -1. What about just 1? Oh, that's 0. What about 2? And that's that decimal 30103. It's an approximation. It's not exact, but it's an approximation. What about 5? 0.69897. What about 10? 1. 100. 2. 1,000. 3. Let's look at that graph again. It's kind of hard to see what's going on there. I'm going to zoom in a little bit. I'm going to hit the zoom button, and I'm going to zoom in. See how this thing's kind of approaching the y-axis here? It's kind of hard to tell in the graph. It's approaching the y-axis, but it's never quite touching it. So let's graph the points we can graph. We can graph that 1, 0. Oops. That's why you always do work in pencils. 1 over 1. Oh, it was right, though. That's funny. And 10, 1. And then, so this graph is going out this way forever. And then what's happening here, you can tell, -1, -2, -3, this thing's going down. And it's approaching the y-axis, but it's never quite getting there. That's what asymptotic behavior is. Okay, so I'm going to draw a little dotted line right there, because that is a line that my function approaches but never quite touches. That's an asymptote. I'll talk about that more in just a second. The domain, how far left, how far right? Well, the furthest it goes is, well, it's approaching 0, but it never quite gets there. So is that inclusive or exclusive? Well, it gets really, really close to 0, but doesn't quite get there. So that's exclusive. How far right does it go? Well, it pretty clearly goes out to the right forever. And it almost gets there. So both of those are exclusive. Now, the question, range, how far left, or sorry, how far down, how low, and how high? Well, I think you can pretty clearly see this thing's going down forever. How high does it go? Now, it may not be immediately clear, but this thing goes up forever as well. It's just going to go really, really slowly. But eventually, see it? You're losing me. It's going to go up there forever. Okay, the y-intercept. Where does it cross the y-axis? Well, I just told you. It approaches the y-axis, gets really close, but it doesn't quite get there. So that's a none. It never crosses the y-axis, never touches the y-axis. The x-intercept, though, does it touch the x-axis? Yeah, it does, right there. It touches right there. What is that? That's the point 1, 0. Maximum, minimum. For it to have a maximum, it has to go up and then come down. This thing goes up, but it's never going to come back down. There's no max. In order for it to have a minimum, it needs to go up and come back down. No, sorry, the maximum is up and down. Minimum is go down and then come up. This thing goes down, but it's never going to come back up after it goes down, so there's no minimum here. Is there any symmetry here? Is there any way we could like cut this thing in half or rotate it so it's the exact same picture? No, there's no symmetry here. Logarithms have no symmetry. And then the asymptote, that line that the function approaches but never quite touches. Well, that's your y-axis, isn't it? That's the line x equals 0. And that's it. Those are the two I'm going to show you. Those are the two for parent functions. Now you'll need to do this other 7 on your own for homework, but hopefully that helped. Again, this has been Mr. Alexander, and I hope this has been helpful.